All right, we're finishing up Chapter 7, looking at 7-7. And we're going to incorporate a new set of numbers. We're going to look at the complex numbers so that we can take the square root of a negative number. So up to now, what have we said in regards to simplifying the square root of -4? We have said no real answer. And that is true. On our known number line, there is no answer. But we're going to move to a bigger number line called the complex numbers. So if we look at this string of number sets, the complex numbers is the largest number set that we'll talk about in this course. All of the real numbers can be found in the complex numbers, but not all complex numbers can be found in the real numbers. So the way this chart works is everything to the right can be found in the left, but not all of the left can be found in the right. So this new set of numbers is called the complex numbers. The real numbers are a subset of the complex numbers. Under the complex numbers, we can take the square root of a negative number. And this is how the box is the most important thing for section 7-7. This is a very important statement. So when we're within the complex numbers, we will let the square root of -1 be equal to I. We will also know that I squared is equal to -1. And this I will be our imaginary unit. So we're going to talk about imaginary values in the complex number system. So now we're going to look at taking some square roots of negative numbers and simplifying them. So if I'm in the complex number system, every time I see a negative under a square root, I will take that out as I. And any other value, I will apply the simplifying rules we've already learned. So the square root of 4 is 2. The square root of a negative is I. So my answer is 2I. For the second one, I can take the negative out as an I, but the square root of 7 I can't do anything with. So I will leave the square root of 7. Standard procedure is to write any remaining radical after your letter I. I is just a variable. It represents the square root of -1. So this is an imaginary answer. The next one, this negative is just a tag along. It will stay. The square root of 81 is 9, and the inside negative comes out as I. So we get -9I. 4, we see the negative underneath the square root, so we take out I, and we have left the square root of 48. But now we need to follow our simplifying rules. When I see a number under a square root, I need to think, is there a perfect square that goes into 48? So I can say 16 times 3. The square root of 16 is 4, so my most simplified answer for this problem is 4I square root of 3. Now 7-7 is broken into many small little sections, so now we're going to work on multiplying square roots of negative numbers. So remember, the product rule that we learned earlier says we can't multiply the square root of -2 with the square root of -3 because this square root and this square root, neither one represent a real value. So here's the procedure. You take the negative out as an I. You then can multiply the i's together for I squared, and now you can multiply 2 and 3 for square root of 6. I squared is always replaced with -1 or negative. So this would be, each of these is equal. You keep going to a simplified answer. So for this one, we'll take out I root 7 times I root 5. We get I squared root 35, and then the minute we see I squared, we swap it out for a negative. The next one is the square root of 11 times the square root of negative 15. Well, if either square root has a negative number underneath, you can't multiply before you take the I out. So square root of 11 times I square root of 15. You get I square root of 165. Now this is I, not I squared. So we can't replace that with negative 1. That stays I. The next one is 6I times 4I, which is 24I squared, which is negative 24, because I squared is representing negative 1. Problem 4, I'm going to take an I out, and I get negative I square root of 8 times I square root of 6. I then have negative I squared times the square root of 48. Negative I squared is positive 1 because I squared is negative 1, so this is really a negative and a negative. So this is the square root of 48, which we have to remember, check for your perfect square. So square root of 48 is the square root of 16 times 3, which is 4 square roots of 3. Now the next part is to divide square roots. Well, the quotient rule says the same thing. I have to take out my I before I can ever think about dividing square roots. I also always want to think about simplifying my radicals. So this is 9 times 2, which the square root of 9 is 3, so I get 3I square root of 2 over the square root of 2, and then these cancel. So I get 3I. So we take out the negative as an I. I recognize 18 has a perfect square sitting inside of it. The square root of 9 is 3. The way to write this expression is write the whole value before the I and always write any radical at the end. We would do the same to problem 2. We would take out our I and get square root of 40 over the square root of 10. I would want to look for any perfect square that goes into 40. Well, I would say 4. So now I have 2I root 10 over root 10, and those cancel out. So I get 2I. Here, actually, let's go back. There's an I down here that I've lost. So the I's actually drop out too, so we get a 3, not 3I. My mistake. The final portion of 7-7 is looking at complex numbers that have both a real and imaginary part to them. An imaginary part will always have I with it. So if a complex number has a real part and an imaginary part, standard form is A plus BI. And so we're going to look at complex numbers that have both a real and imaginary part. And we're going to work on, first, adding and subtracting. So this is negative 1 plus 2I minus 4 plus I. So all I have to do here is distribute my sign. So I get negative 1 plus 2I minus 4 minus I. And then I combine like terms. Notice it says to put your answer in A plus BI form, which means the imaginary values, the parts with I, should be written last. So I'm going to combine these first for negative 5, and I'm going to combine these second for plus I. I can't add I onto negative 5 because they're not like terms. So that's my answer. This one is 7 plus 3I minus 4 minus 2i plus 2 plus I. So here I'm going to distribute my sign through 4 minus 2i. These parentheses are serving no purpose, as are these. So I get 7 plus 3i minus 4 plus 2i plus 2 plus I. And then I want to combine first those values that have no I with them. So I want to combine 7 minus 4 and 2. So I get 5. Then I want to take the expressions that have the I with them and combine them second. So I get plus 6i. And that would be my complex number. The last thing 7-7 wants you to learn is multiplying imaginary values. So it's really a lot of distributing and foiling. So this would be negative 21i squared, which again, I squared needs to always be replaced with negative 1. So our answer is positive 21, because this is a negative times a negative, which is a positive. Here I'm going to distribute, so I get negative 30i plus 10i squared. Every time I see I squared, I'm going to swap it for a negative value. And again, I want to write my answers in A plus BI form. So I want to pull negative 10 to the front minus 30i. Again, negative 10 came from I squared really being a negative. So this is a negative 10. Here, you're going to FOIL. So you're going to get 4 minus 8i plus 3i minus 6i squared. This you have to immediately take care of. So you get 4 minus 8i plus 3i plus 6, because it's a negative with a negative. A plus BI form says combine first those terms that have no I. So we're going to get 10 minus 5i. Last part, I need to write this twice. So negative 4 minus I times negative 4 minus I. I'm going to FOIL first. So this 2i is still out here. So I get 16 plus 4i plus 4i plus I squared. I immediately need to take care of this. Never leave it. Always change it to negative 1. So this is 2i times 16 plus, I can write 8i if I add those together, minus 1. Now it's 2i, and it's 15 plus 8i if I take 1 from 16. And now I distribute. So I get 30i plus 16i squared. And then again another I squared, which means a negative value. A plus BI says the value without I should be first. So my final answer is negative 16 plus 30i.